Part 1. The Paradox of the Transporter. Remember the last time you saw a transporter in a movie? A character steps onto a metallic pad, there's a cool humming sound, a shimmering light, and poof, they're gone. Seconds later, they're walking around on a distant planet, checking their gear like nothing happened. We've seen this so many times that we just accept it. We assume the shimmering light is basically a high-tech subway. We assume the you that steps onto the pad is the exact same you that steps off. But if you stop looking at the special effects and start looking at the actual physics, specifically quantum mechanics, the reality is a nightmare. The scientific literature doesn't describe teleportation as travel. It isn't a movement of the self through space. It is a process of reconstruction that requires the absolute, literal destruction of the original. Let's call it what it is. A transporter is not a vehicle. It is a suicide machine that creates a perfect imposter. Before we start, we need to get one thing straight. Quantum mechanics is not easy. The math that governs it is dense, counterintuitive, and frankly, a headache. But don't panic. This video isn't a lecture. I'm not going to bury you under a mountain of complex formulas or academic jargon. Instead, we are going to focus on the logic. The simple, terrifying rules that hold the universe together. Stick with me. By the time we reach the final chapter, you won't just understand the mechanics of teleportation. You will understand exactly why stepping onto that pad might be the last thing you ever do. To understand why this is the only option, we have to look at the massive gap between pop culture and what the laws of physics actually allow. Science fiction usually relies on a matter stream. The idea is that the machine takes your atoms apart, shoots them across space like a fire hose, and puts them back together on the other side. But physics doesn't work that way. If you tried to convert the 70 kilograms of atoms in your body into pure radiation to beam them, you wouldn't be traveling. According to Einstein's formal energy equals mass times the speed of light squared, you would be releasing approximately 1.5 gigatons of energy. That is the energy of total mass annihilation. To put that in perspective, the Tsar Bomba, the largest nuclear weapon ever detonated, was about 50 megatons. Teleporting a single human being via matter-energy conversion would be the equivalent of detonating 30 Tsar Bombas at once. It's not just a shimmering light, it's a planetary-scale disaster. The radiation pressure from a beam that powerful would turn your departure pad into a rocket engine, capable of pushing the Earth out of its orbit and stripping away the atmosphere. The only scientifically viable method we have is quantum teleportation. Discovered in 1993, this protocol changed the definition of you from a collection of matter to a collection of pure information. And in doing so, it opened a door to a metaphysical horror that we are only just beginning to understand. Part 2. Information is physical. In the quantum world, we have a golden rule. Matter doesn't move. Information moves. Think of it this way. You aren't your physical atoms. You are the arrangement of those. You are the song, not the radio. You are the story, not the book. The goal of teleportation isn't to move the paper and ink. It's to move the story to a new book. But there is a trap. In our universe, you cannot read the story without burning the pages. To visualize this, imagine you've built a complex, perfect sandcastle on a beach. To teleport this castle to your friend, you can't just snap a photo. You need to map the exact position of every single grain of sand. But in the quantum world, measuring is a contact sport. To know exactly where a grain of sand is, you have to dig it out. You have to disturb it. By the time you have written down the blueprint for the entire castle, the original is nothing but a flattened, chaotic pile of sand. You had to destroy it just to read it. You send that blueprint to your friend. They use their own sand, fresh sand from their own beach, and follow your instructions perfectly. The result? An identical sandcastle stands on their beach. It looks the same. It is the same structure down to the last grain. But the original sand is still sitting in a flattened pile on your beach. This is the reality of teleportation. The you that wakes up on Mars is made of Martian atoms. Physics says this is fine. Atoms are just generic building blocks. But the continuous movie of your life? That film was cut, and a new reel started. The spatio-temporal continuity, the unbroken path of your body through time, has been severed. By the way, if you're enjoying this trip through the quantum world, do me a favor and hit that like button. Consider subscribing so you don't miss out on the next mind-bending mystery. It really helps the channel. Part 3, the moment of quantum projection. The method we use is called the Bennett Protocol. It relies on quantum entanglement, two particles sharing a single wave function. This entanglement is a quantum resource. It is the fuel that powers the teleportation. In the Bennett Protocol, you and your friend must first share an Einstein-Podolsky-Rosen pair. This is the quantum bridge. You perform what we call a Bell state measurement. This is the moment of quantum projection. By measuring the traveler and your half of the bridge together, you force them into a joint correlation. This measurement projects the traveler's information into the bridge. This instantly erases the traveler's original independent identity. The wave function collapses. The information does not travel through the entanglement. That would violate the No-Communication Theorem, which prevents us from sending information faster than light. Instead, the information is effectively locked in a non-local state. To your friend on the other end, their particle looks like pure random noise. It has what we call a maximally mixed state. It is a lock without a key. You have to send them the transformation key. The protocol is mathematically strict. For every 1 qubit of your soul, you must send exactly 2 classical bits of data. For a human being, that is a data tsunami. Because this data travels at the speed of light via normal channels, teleportation is not instant. The universe enforces a cosmic speed limit by hiding the results until the classical signal arrives. Part 4. The no-cloning barrier and universe DRM. You might ask, why not just make a backup? If I'm going to be destroyed, why not keep the file so I can be printed again if something goes wrong? The universe has a hard rule against this. The No-Cloning Theorem. Think of it as digital rights management for reality. This isn't just a technological hurdle. It is a mathematical proof. Because the equations that govern our universe are linear, you cannot produce 2 identical states from one. If you could clone a state, you could measure the position on one copy and the momentum on the other, effectively hacking the Heisenberg uncertainty principle. Reality prevents this to maintain causality. There is no Control-C in the universe. There is only Control-X and Control-V. The original must be deleted from the source folder for the copy to appear in the destination. This isn't a flaw in the machine. It is a physical requirement of the logic of existence. The no-hiding theorem reinforces this. Information is conserved. When the U is destroyed on Earth, that information moves into the correlations of the environment. The math of the universe is a closed loop. If the information appears at the destination, the source code at the origin is mathematically required to be empty. You are being unmade here, so you can be remade there. Part 5. The resolution trap and the data nightmare. Even if you accept the destruction, you hit the resolution trap. At what level does the self actually live? A human body has 7 octillion atoms. To store and transmit a person, we have to decide how much detail we need. If you are just a software package, the map of your neural pathways, or the connectome, the data is roughly 10 to the power of 15 bits. That is about 125 terabytes. That's a pile of hard drives the size of a small house. We could transmit that in a few minutes. You'd wake up as a digital ghost. You would have your memories, but you would lack the physical substrate of your body. You would be a simulation, a high-fidelity video game character who thinks he's a man. But what if consciousness requires the subatomic quantum state? If we have to teleport at the subatomic level, we run into the Beaconstein bound. This is the theoretical maximum amount of information that can exist in the volume of a human being. It's roughly 10 to the power of 45 bits. To put 10 to the power of 45 bits into perspective, if the total capacity of the global internet is a single grain of sand, the data for your quantum state is the size of the entire planet Earth. Transmitting that much data is a cosmic impossibility. Even with a theoretical bandwidth of 1 terabit per second, it would take 31 septillion years to send the map. To put that in context, that is 2 quadrillion times the current age of the universe. The pause between dematerialization and reconstruction would outlast the stars themselves. You wouldn't just be dying, you'd be drifting as a data packet in the cold void until the very last stars burn out. By the time your friend gets the receipt to put you back together, the very protons in his body might have already decayed. You would be reconstructed into a universe that has already ended. And if we try to lower the resolution, we run into the Heisenberg uncertainty principle. If we skip the quantum states, we might reconstruct the body, but we might lose the soul, the delicate quantum balance that makes you conscious. You might wake up on Mars looking like yourself, but being what philosophers call a philosophical zombie, acting like you, speaking like you, but with the lights turned off inside. Part 6. Parfit's Nightmare and the Branch Line Case. The physics leads us directly to the philosophy of Derek Parfit and his famous branch line case. Imagine you enter the booth on Earth. The machine scans you and creates a copy on Mars, but it malfunctions and fails to vaporize you on Earth. Now there are two of you. This is the ultimate proof that the person on Mars is not you. The Earth you steps out of the booth and sees Mars you on a screen. Mars you has your memories and your voice. They are greeting your spouse and playing with your children. But the technician tells Earth you, the scan damaged your heart. You will die in 5 minutes. But don't worry, the other you on Mars is fine. In this moment, Earth you is clearly dying. The existence of an identical copy doesn't stop your heart from stopping. You don't jump into the other body. Your stream of consciousness is separate. You are the one who will experience the dark. Parfit's point is that the simple case where you are destroyed instantly is exactly the same. Teleportation is just a malfunction where the Earth U life expectancy is reduced from 5 minutes to 0 seconds. The fact that the copy survives doesn't mean you survived. It just means a successor was appointed to take over your life. If your brain is hurting in a good way right now, do me a favor and smash that hype button. It really helps push this video to other people who need a little existential crisis in their day. Part 7. The Perspective Paradox. We can strip away the cinematic gloss and look at the perspective paradox directly. Imagine a machine where the scanning process is inherently lethal, a mechanism that requires the original to be submerged in a tank of water while the duplicate appears elsewhere. From your perspective, you aren't beaming anywhere. You simply die in a tank while a stranger with your face takes credit for the miracle. To a physicalist, there is no difference. If the copy is functionally identical, then you have survived. But to the subjective observer, the experiment is a failure. 100% of the people who walk into the booth experience death. 100% of the people who walk out of the booth experience a successful trip. Quantum teleportation solves this by ensuring the original is vaporized during the scan. There is never a moment where both exist. But the lack of a corpse doesn't mean there wasn't a murder. The version that steps out on the other side is always the copy. The silence of the originals is the foundation of the technology's success. Every user says it's safe because the originals are too dead to complain. The copy arrives with the memory of the blink and tells the world it was a success. We only listen to the winners. Part 8. The Ship of Theseus and Quantum Indistinguishability. But wait, you might ask, isn't it true that particles have no identity? And you would be right. In quantum mechanics, if you have two electrons in the same state, there is no physical property that distinguishes one from the other. In normal life, your body is constantly exchanging matter. You breathe in atoms that were once part of a star. You eat atoms that were once part of a plant. But while your atoms swap out over years, the process is gradual and overlapping. There is spatio-temporal continuity. There is a continuous, unbroken line of existence from your birth to your death. Teleportation snaps that line. It is a hard reboot of the entire system at once. It is the difference between a river that flows continuously and a river that is dried up, removed, and then a new river is poured into the same channel 1,000 miles away. Part 9. Quantum consciousness. If we want to get really controversial, we look at theories suggesting consciousness isn't just a result of neuronal firing, it's a result of quantum computations. If this is true, then a classical scan is a death sentence. To move the soul, you would have to move the delicate quantum superposition state of the entire brain. This brings us back to the no-cloning theorem. You cannot copy a quantum state. You can only move it. And to move it, the original state must be destroyed. The universe does not allow for two yous to have the same consciousness. This means that teleportation isn't just hard. It's a high-stakes gamble on the very nature of existence. If consciousness is quantum, then the pattern isn't enough. You need the exact, fragile, uncopyable state. And the moment you measure that state to move it, you are committing a form of cosmic suicide. Part 10. The conclusion. The existential void. Does consciousness continue, or does it reset? This is the ultimate question of the transporter. We experience gaps every day like sleep. We assume we are the same person because our body stayed in the bed. There is a physical bridge, a steady causal chain of neural activity. Teleportation destroys that bridge. Some argue that even sleep breaks the self, that the you of yesterday died, and a new consciousness booted up this morning, accessing your memory files. If that's true, teleportation is just a nap. We're already a series of copies, blinking in and out of existence with every breath. But if consciousness requires a continuous physical substrate, a steady glow of information processing that never hits zero, then the verdict is inescapable. A teleporter is a machine that kills the user and creates a perfect imposter. First, destruction is mandatory. The no-cloning theorem ensures the original is destroyed. There is no backup. Second, continuity is illusory. The person who arrives is an identical copy, indistinguishable by any physical test, but a copy nonetheless. Third, the perspective gap. From the copy's view, it worked. From the original's view, they died. To teleport is to accept that you are replaceable and to voluntarily end your own existence in the hope that your successor will carry your torch. It is the ultimate act of faith and the ultimate form of surrender. You are trusting the universe to reboot you correctly while knowing that the you who stepped onto the pad will never see the other side. I wish you the best of luck.